All right, this is Math 209, Week 4, Section 10.3. Now we're going to be multiplying and dividing all these radical expressions. All right, so let's simplify this expression. So what does that mean? Well, okay, so we're going to be putting things together and tearing things apart. And so root 2 times root 2. So I'm going to do it the long way for starters. So we know that that's equal to root 4. All right, so now what does that mean? So remember, there's a 2 there if there's no specific number written. And when you have the square root of 4, you're basically saying what times itself is equal to 4. And the answer is 2. Yes, the answer is also negative 2, but we're only going to be dealing with the positives in this lesson. So the answer is 2. All right, for simplifying this one, they're actually giving us a hint to use the product rule. Let me show you what that means. So they've got the square root of 5 times the square root of 125. That means we can put them together and get the square root of 5 times 125. And then I can start breaking things apart. And I'm going to decompose 125. I'm going to factor that. So it becomes 5 times, and then when I factor 125, I get 5 times 5 times 5. All right? So 125 is 5 times 5 times 5, and we had the 5 original. All right, so now, remember, what's this number right here? Well, if there's no number, it's a 2. And the Duane way of doing this is when there's a 2, it means you circle 2 5s, you cross them out, and you write 1 down. And then look at that. Hey, we got another one. So we're going to circle another 2 5s, cross them out, write it down. And then what do we have left over inside our root? We have nothing. So that means we can just ignore that whole thing. And what are we left with on the outside? 5 times 5, which is 25. So the answer is 25. All right, so simplifying the cube roots. So we've got cube root of 7 times the cube root of 49. So we're going to combine those together. That gives us the cube root of 7 times 49. Now I'm going to factor that 49. Because 7 is prime, it cannot be factored any further. So I see that 49 is 7 times 7. And so now we've got the cube root of 7 times 7 times 7. So how do we simplify that? Well, we know that it's a 3, a third root. So that means we're going to circle 3 7s, cross them out, and write 1 down. And then what are we left with inside that radical expression? Nothing. So that means that whole thing goes away. And we are left with just the answer of 7. All right, so this is where our rules are continuing to make sense. So when you've got the square root of 16 over 25, you can break that apart into the square root of 16 over the square root of 25. And that gives us 4 over 5. And we are officially done. Now, how did I get that? Well, don't forget, when there's no number, that means it's a 2. And so this is saying what times itself is equal to 16. And this is saying what times itself is equal to 25. So the answer is 4/5. All right, so simplifying this expression, you've got root 1/4 times root 1/25. And actually, what I would do here is I think I'd break them all apart. So I'd do root over 1 over root over 4 times root over 1 over root 25. And then all of these. So 1 times 1 is 1. So that equals 1. And then actually I could just do that over here as well. So both of these are equal to 1 because 1 times 1 is 1 and 1 times 1 is 1. So what's the square root of 4? It's 2. because 2 times 2 is 4. Now what's the square root of 25? It's 5, because 5 times 5 is 25. And now fractions, that's easy. So 1/2 times 1/5, that equals 1 over 10, 1/10. And there's our answer. All right, so now this, it's going to get a little ugly, but only because students don't like fractions and stuff, and they don't like radicals. They want them to all go away. But here, check this out. So we're going to take this fraction and we're going to break it up. So it's going to be root 3 of 9 over root 3 of 8. All right, so now I'm going to break this out a little bit for you. So this is saying what times what times what is equal to 8. And the answer is 2. 2 times 2 times 2 is equal to 8. So that tells us the denominator is equal to 2. Now, if you think about the numerator up here, this is saying what times what times what is equal to 9. And the answer is there is nothing, no whole number. And they want us to just give us whole numbers here. And since the answer is there is nothing, we just leave it alone. So our answer is the third root of 9 over 2. And that is our answer. You leave it alone like that. All right, so here, divide and simplify. So in this case, they're actually giving us a hint to divide first. So when you have root 63 over root 7, that means we can combine them together to get root 63 over 7. And root 63 over 7 is equal to 9. So that ends up being root 9, because 63 over 7 is equal to 9. So now this is saying what times itself is equal to 9, and the answer is 3. All right, so they kind of gave us a little hint. They said first take this, combine it together, and divide. Then you get 3. So they're taking away some of the scaffolds here, and so we end up with the fourth root of 25 times the fourth root of 25. So we're going to, now we know that 5 times 5 is 25, and 5 times 5 is 25, but we need the fourth root. We only have, would only have the square root. And so now what we're going to do is we're going to use the rule and we're going to combine them. So you get the fourth root of 25 times 25. All right? And so what does that equal? That's the fourth root of, and now I'm going to take each of these and factor them. I'm going to break them apart. So I get 5 times 5 times 5 times 5. All right, and then using the Duane method, the 4 says to circle 4 5s, cross them out, and write 1 down. We're left with nothing under the radical, so we just drop it. So our answer is 5. All right, so here it's getting ugly, but it's really, and it says assume all expressions under the radicals represent non-negative numbers. Don't freak out about that. Ignore it. They're going to give you nice, simple numbers. They're not going to give you any complex, what's called imaginary numbers. So don't worry about that. So you got negative 16 x to the 8th power. Now, I'm going to factor negative 16 in a kind of a curious way. And that's going to be negative 1 times 16 times, and then we have x to the 8th power. All right? Now, the reason I did that is because now we're going to break them apart. So we're going to have the third root of negative 1 times the third root of 16 times the third root of x to the 8th. All right? So now, really, I wish I could, okay, I'm going to take this and we're going to copy that and we're going to put it over here because I actually need more space. All right? So I'm going to do that. So let's go, so I'm going to go equals, okay, third root. Now, I'm going to also at the same time, I'm going to expand these. So I'm going to use the prime factorization. I'm going to factor these. So the third root of -1 is a little on the tricky side because that becomes third root of, now check this out, it's -1 times -1 times -1. That's a surprise, right? And times, and now I'm going to factor this. So the third root of, and it becomes 2 times 2 times 2 times 2. All right, so I factored that. And then times, and then the third root of x to the 8th becomes third root of x, 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 x. All right, so all I did was I took this and I wrote it in expanded notation. Now we can simplify. So what's the third root of -1 times -1 times -1? That's -1 times, what's the third root of 2 times 2 times 2 times 2? Well, I'll be more explicit. I won't jump the gun like I did over here. Because really, what did I do over here? I said, oh, I circle 3, cross it out, and write 1 down. So that's what I did. So what are we going to do over here? Well, we're going to do the same thing. We're going to circle 3, cross it out, write it down. And then what do we have left over? You have the third root of 2, because that's what's left over, is a 2 inside. So you still have a third root of 2 left over, times, and then let's do this one. All right, so this is saying third root, so we're going to circle 3 x's, cross it out, write 1 down. And then we're going to circle 3 x's, cross it out, write 1 down. And we're left with the third root of x times x. So simplifying this. So you've got, let's see, we've got -1. Well, actually, what we could do is we can actually multiply. So we could say, hey, that's -1 times 2. So that gives us -2. Then we have the third root of 2 times. Then we have x squared. Then we have the third root of x squared. All right, and that's how we went from this line to this line. We're still got one little bit more step to go because now we can kind of clean this answer up. Technically, we've got the answer, but I can see that -2 and x squared can go together. So that's -2x squared. And then I can see that we can combine, using our rule, the third root of 2 and the third root of x squared. So that becomes the third root of 2x squared. And now we are officially done. Man, look at all that work. That's a lot of work for one problem. That's cool. And this one, gloriously, with all these letters, it actually becomes simple. So you've got the square root of 4m to the third times the square root of 4m. So we can combine those and mush them together so you get 4 times m to the third times 4 times m. And now we're going to expand that. So I'm going to go over here and we're going to expand that. So that becomes the square root of. So it becomes 2 times 2. And I'm going to do a little commutative property. So I'm going to take this 4 and this 4, put them next to each other. And then we've got times m times m times m times m. All right, so I just took this and wrote it in expanded notation. I factored it out. And remember, when we don't have a number there, it's a 2. All right, so this says circle 2, cross it out, write 1 down. 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 And in our radical expression, we are left with nothing left over. There's nothing in there, so we can just ignore it. And so our answer becomes 2 times 2 times m, so that becomes 4m squared, and we are done.